I'm so excited to hear the answer. What'd you say, Maddie?
5,005.
5,005?
I think so. That's
Okay.
That's what I remember.
And actually, by the answer, I meant how do you do it? Is actually what I was excited to hear.
Sorry.
It's all right.
15 choose 9.
15 choose
Or 15
9.
choose 6 is the same thing.
Wait, what? You're kind of blowing my mind here, Maddie. All right, I'm gonna write this down, but I don't know if I trust you yet. I'm just gonna write it down. You say it's 15 choose 9, aka 5,005. Is that what you said?
Yeah.
Okay. Yeah, Jeremy.
Don't we have to multiply about 15 choose 9 times 15 choose 6?
Yeah, like that's what I'm here. I'm like, I feel like we have to make this decision for Selma, and then we have to make this decision for Reem, don't we?
Well, that would be either if Selma had 9 and then Selma changed her mind and Selma also wanted 6 again. But since they're both going to 15, the ones that aren't going to one are going to the other, and it adds up.
And it adds up or something. Okay. Yeah, go, Thomas. You seem excited about this.
So if someone goes first and someone takes 9, then it's 15 choose 9, and that's agreeable. And then there's only 6 left for Reem. So then Reem has 6 to choose from, and she wants to choose 6, so it's 6 choose 6, which is 1.
Yeah, you could conceptualize it that way. She has like no choice left in her life. It's kind of sad for Reem. Yeah.
So 15 choose 9 is 15 factorial over 9 factorial times 6 factorial over 15 choose 6. 15 factorial over 6 factorial.
Oh, you're underscoring the thing Maddie said again. You're like proving to me that in fact 15 choose 6 is the same.
Yeah.
Like we could do it either way. And you can just look at the way, like go to the definition and you'll see. Noah says, you'll see. Work it out. You'll see that it's the same. And yeah, maybe you could prove that in general it's true that n choose r is equal to n choose n minus r. Is that always the case? Maybe we could prove that in general for a general n and a general r. So these are great questions that are coming up. The answer is right, though. We don't have to multiply anything else here. It is, in fact, just 5,005. There's no other decision to make. For Reem, once Selma chooses the 9. Imagine like having 15 pencils on the table here. Like how many ways can I walk away with 9 of them? And the answer is it's exactly the same number of ways that I can leave 6 on the table, right? Like in fact, why would I even ask it? It's the same question, really, isn't it? Just two views, from Selma's view or from Reem's view here. Okay. By the way, I picked these names. I thought they were really creative.
Yeah.
But they don't. Yeah. Yeah. You don't know.
Their parents thought so too.
Yeah. Okay. I mean, I don't know anyone with those names. I was just putting that up there because I thought they sounded like good names if 2 people had those names. All right, we're gonna learn something called the binomial theorem today. Does that sound like fun or what? Yeah. Okay, and I'm gonna start you off with some busy work. Are you ready for some busy work?
Yeah!
AKA
Go to school.
AKA fun activity, it says at the top. Here we go, okay? I'd like you to expand the following binomial. And if you happen to know like a shortcut, if you're that person who knows the shortcut, then you and me, we know what we mean. Okay, don't spoil it for anyone, first of all. And second of all, maybe just do these by hand anyway, because maybe the shortcut you know you don't actually understand. Okay, so let's actually all do this by hand. I'll do the first one for you just because that's the kind of guy I am. Here you go. There you go. Okay, you do the rest.
What a nice guy.
Yeah. All right.
We all love you.
Don't cheat.
Okay.
I know.
I'm counting it in my head. Like, I'm doing it in my head, I promise. I promise. I'm very good.
The second one, I can do that one for you too. It's A plus B. You're welcome.
Thank you very much.
Yeah, I know. Don't say I never
I
did
had
it.
to learn this for my IA, and I already forgot it.
What's that?
Elvin.
Busy
It was
work.
on like words and whatnot, but I had to learn derivatives.
Yeah, busy yeah.
Yeah, but it has to do with, or doing the.
It's good for you. You're probably also already done with a plus b squared, I would imagine.
I'm gonna try 8
If someone has a plus b cubed, though, I'd like to see it. Are you that person? Who are you? There's no stupid formula. I don't know any formulas, actually. I don't know any formulas.
Formula?
I don't know any formulas.
Yeah.
Don't know.
Charlotte got it.
It's probably wrong.
A squared b plus 2, a squared plus
Okay, you know, I'm gonna write it out as A's and B's. See how we go. A. Got it.
I got the cube one, but not the other one. It's fun.
I'm doing binary today.
Here I'm like, what's b squared? You're right? Say hi to that one over there. And I think you'll have it.
I have the third one,
I have it
but
to the
I'm
fifth
working
one.
on the,
Who has a plus b cubed done here too? I'd like to. Who is you? Who's the first?
Shut up, Alex! Somebody knows. Miss Brown sometimes says.
This is what I've been talking about.
Let's replace.
There's so many shorts. They're like crazy. I'm so excited about it. I didn't make it. But David, who did?
Oh, yeah.
My handwriting just deteriorated.
Wait, you guys know my friend? I was no wait, I was right. What are you gonna fight? I got
Mr. Chase, I got an 8 plus B to the 4.
it's a pattern.
I know, I'm proud. I'm so smart.
I got and like prior from Russia. Whoops. Yes, you can, but you know what you can also do? Why? If you want to. Incredibly useless. This is the why. So you're gonna screw.
Ireland?
You're gonna
I've never been there. And I'm like 8th generation Irish, maybe. One of my ancestors at some point got it here. I think.
All right, I've got the second, a plus b squared, and we've got a plus b cubed coming up here in a second. It's going to be there any second. Let's see if you got the right answer. A squared.
Yes.
If you didn't get a plus b to the fourth or a plus b to the fifth, that's okay. I'll
Can I
do
do
it.
the fourth one?
No, it's all right. Did you get the right answer though? Okay, good job.
Oh,
All right, and then someone point out, someone spoil it for all of us. What do you see? Just emerging, and actually I've gone out of my way to make this happen. Like I wouldn't normally write 1a plus 1b, but I did for the sake of the argument. And if you can't see it yet, now, can you see it now?
Are you feeling it now, Mr. President?
Is that magical or what? It's in red. Can you see it now? Or orange or whatever. So maybe you can even do a plus b to the 6 without actually multiplying out. But we're observing a pattern. A lot of you have, like, maybe you've seen this before, or maybe this is the first time, maybe too, that you're experiencing this moment of wonder. But of course, the moment of wonder is important, but obviously, we're in math class, we'd like to understand why that happens too. So there's there's a story to tell there, for sure, why this is happening. No, it's still beautiful. Right? It's still beautiful. Even if you can deconstruct them here, it's still beautiful. All right. So here's, whoa. I'm ready to hand you the binomial theorem. I'm ready to give it to you. Just like that. It may or may not be in the hallway on the wall. Above missing links. Could, maybe not. Are you ready? Are you ready?
No.
I think you know how to write the rest of the slide down, even if you haven't yet. You know what I'm saying? Like I think, well, actually, before we go to the next slide, maybe there's some things we should notice, right? It's certainly true that we expect in the expansion a plus b to the 5th, we expect there to be like an a cubed b squared, right? And we expect there to be like a b to the 5th in that expansion, definitely. And then the only question that still remains is the coefficients, but it's definitely true that we have every combination of powers such that those powers add up to, in this case, 5, right? So that's something to notice. We should notice that we've got some nice symmetries here as well. You know, the powers of A go from high to low, and the powers from B go from low to high. There are lots of things to notice. All right, so this would be the startling result now. Okay, this says a lot, and it's got all these triple dots, and I apologize. Maybe that's a little intense for you to see, but we're going to go with it. And yes, the answer is yes. Those are the things that we've been doing this whole unit. Those are combinations. And it still remains to be explained why those are popping up here. So we will do that. Stephen, I might have you do a little explanation on this too. I like what you said. And so just to be clear, because this looks like we need to kind of deconstruct this. We've got the powers of A going from A to the n down to A to the 0. In fact, down to the last one there, maybe you just don't write A to the 0, right? And the powers of B go from B to the 0. Again, maybe you just don't write that. All the way up to B to the n. That part makes sense to me, Mr. Chase. But why are the combinations there? So in general, we have, this is like the general binomial term right there in the middle. N choose K, which is that power on B. So let's do A plus B to the 6th. Let's expand it out. Maybe you could have already done these. You can just add this to your next line, right? If you like. There's definitely, even if you didn't know anything in your life, that's definitely A to the 6th. Definitely there's an A to the 5th B in there. Definitely there's an A to the 4th B squared. A to the 3rd B to the 3rd. A to the 2nd B to the 4th. A to the 1st B to the 5th, and a B to the 6th term. But I haven't figured out what the coefficients are yet. But even if you didn't know this theorem, you would have written that down. You'd been like, well, I know that those will all come up at varying degrees of frequency in my expansion, and I'll have to combine like terms. And we just have to figure out what those coefficients are. So yeah, I think that there are, how many ways does A to the 6th show up? And the answer is just one way. I think A to the 6th has a coefficient of 1. But I'd like to maybe, can you explain, I'm going to write this out, Stephen, and maybe can you explain, for example, why A to the 4th B squared has a coefficient of, well, what is the coefficient? I mean, talk to me about this. I'm going to write this out while you talk.
Okay, so basically, if you write it out, then you have A plus B how many times? Or 6 times, right? So you need to choose 4 of the 6 A's.
Okay, like how about this one? And this one, and this one, and this one.
Yeah, and then
Okay.
the other 2 will be B's.
Got it.
So you need to pick 4 A's for that term. So you count how many ways there are to pick 4 A's from the 6. So it'd be 6.
Oh, wait, I know. I learned this earlier this week. It's wait, what is it? It's 6 choose. 6 choose 4. Yeah. I remember that. Yes. Okay, keep going.
So now that you have that, that's the other 2 EQs, and so with that number, you know the focus.
Don't we also have to account for how many ways there are to pick 2 Bs though?
But it's like leftovers, so there's only one way to choose.
Oh, because it's like we've already taken care of that once we pick the A's. This seems really familiar. Like I feel like I did a problem with like pencils or something. Yeah. Earlier. Yeah, do you remember that? That sounds familiar too. Okay. Yeah. Okay, so what you're saying is you could put 6 choose 4 there, or 6 choose 2. They're the same thing, right? It doesn't matter. You know, they're the same thing. In fact, actually, 6 choose 2 is technically what this formula calls for. We march up from the bottom, but who cares? Feel free to say 6 choose 4, whatever. They're the same. So is that a good explanation? That's in fact the exact way I would explain it to you. I like that explanation. There are 4 ways to choose 6. There's 6 choose 4 ways to choose 4 A's from among these. This is one of them, but there are other ways too. So I'm going to go through and put these in here. This is 6 choose 1. This is 6 choose 0. This is 6 choose 3. 6 choose 4. 6 choose 5 B's, and 6 choose 6 B's. All right? And without a calculator even, I know what this one is, right? We already talked about it. It's 1. There's one way to pick no B's. Can we do that one without a calculator too? What's 6 choose 1? How many ways are there to pick exactly one B? Obviously, we can choose this B or this B. There are 6 ways to do that. 6 choose 2. Actually, wait. I need a calculator here. We're gonna blow your mind with some calculator skills today. Where's my calculator when I need it? Calculator, where are you? Ah, there you are. Oh, I already gave it away. Shoot. All right. If you type in 6 on your calculator, math, go over to PRB. You know, you've done this before. But then if you type in this, are you ready? This is the part that's going to blow your mind. 0, 1. You can already tell where this is going, right? 2, 2, 3. Come on now. 4, 5, 6. Right? You like that? I know you like that. Okay. Thank you. I'm here all week. Okay. So there we go. Those are all the numbers we need, right? We need a 15 in there and a 20. Okay.
We all got errors.
Oh wait, but I can't do this my first name.
I don't know. Maybe you're doing it wrong.
I can't do it.
It has to be curly braces. Curly braces. It's second parenthesis, I think, or something. All right. But wait. One other thing to say, though, I guess too, is the fact that why does this connect with Pascal's triangle at all? We haven't really stopped to explain that, but maybe you can go back and think about that a little bit. We will actually prove algebraically that result tomorrow. So I do have 2 more things to say about Pascal's triangle before we leave today. So maybe we'll come back to that in a minute. But let's make sure we have the mechanics down of this, and then we'll come back to Pascal's triangle. But that should remain a question lingering in your mind. I think you're pretty clear on Stephen's explanation, like why the combinations arise. Okay, well, why that connection with Pascal's triangle? That's still a good question in my mind. So think about it. All right. So is this clear? What I'm asking you to do on this first one? I'd rather not expand it out. By the way, how many terms are there in the expansion? How many terms would there be? Yeah, it's n plus 1 in general. It's 16 terms, actually. So I'd rather not write out 16 terms, so we're just saving time. What's the x to the 12th, y to the 3rd term? There definitely is one, right? Because 12 plus 3 is 15. So there definitely is such a term in that expansion. And all I'm asking right now for is the coefficient, so tell your neighbor what that is. Say, neighbor, it's, and then fill in the blank. I mean, you don't know what it is off the top of your head maybe, but how do you get it? Tell your neighbor. And then you can compute it afterward if you like, that's fine. Alex, say it like you mean it though, go. What is it?
It's either 15 choose Palmer, 15 choose 3.
Yeah, it's whatever you want it to be. There you go. Okay. And what is that? Did you compute it? What did you say? 455? Yes, people out there? You're just going to trust Teo, or are we going with it? Okay. All right, next problem.
15 over 15.
So think hard about this here. Let's make sure you're clear on the question first, right? I'm looking for the m to the third term and the m to the sixth term in this expansion. And wouldn't you agree that we definitely are going to have an m to the 13th, an m to the 12th term, an m to the 11th term, all the way down to a constant term? Yeah. So I'm just asking, what is the coefficient on the m to the third term, for example, or the m to the sixth term? And the fact that we have only one variable actually is starting to confuse you maybe. You're like, up here, I prefer Mr. Chase to you ask me about x's and y's. But that's okay. X is m, and y is -2. There we are. Right. Do it. That is, what did I just say? I want m to the third for this first one, m to the third, and then we want -2 to the what? 10. Don't you agree that that term it'll be x to the third, y to the 10th, somewhere in our expansion, right? Okay. Okay, but wait, one more thing too. We need a binomial coefficient, don't we? What is that going to be? 13 choose something. How about 13 choose 3? I don't know, whatever. So we need to work that out.
If you change the -2, would you put that in the beginning plus?
Yeah, I mean, in the end, I want in this expansion, there's definitely going to be an m to the third term. And it's going to be some number times m to the third. I'd like to know what that number is. So I'm getting 286 for the binomial coefficient. And then that's 1,024. So what do we get? 292,864 m to the third. So what does that mean? What was the question? That means A is 292,864. Okay. Okay, so do that same process for B, and let's do that quick here. That is, what's the m to the sixth term? I want to know what B equals.
What are we supposed to do right now?
I want that one now. Right? Yeah. Well, you're done with that. You can do the next one. Yeah. Yeah. So here we get what? M to the 6th, -2 to the 7th. And over here, 13 choose 6 or 13 choose 7, whichever you prefer. And in the end, just give me the answer. It's my favorite part of that was negative, whatever. I don't know what the rest of you said was, but it's negative something. Okay, this is the thing I'm noticing. No, I am ready for it to hear it again.
219,648.
219,648. All right, make sure we got that right. But notice here that it's negative. I just want to make sure you're aware. The reason it's worth doing both of these problems is to just make you aware that it could be negative. In fact, if you were to write out the whole expansion with 14 terms in it, it'd be alternating signs, positive, negative, right? Because of the parity of the exponents on -2, right? Sometimes it's odd or even, so that matters. All right, moving smartly along. Do this one now. This time I want you to expand the whole thing, so do it. Yeah, so here, this is gonna come out to be 1326 is gonna come out to be something, I don't know what. Negative 2 to the 7th will be come out to be, actually I think I know it. It's negative 256. No, negative 128. It's negative 128 is what I meant. Times some other number, which I'm not sure about what it is. It's gonna be a negative number, right? Is that okay? Yeah. We're looking for the total thing that is attached to n to the 6 is what we're aiming at. Did you do it? What's interesting about the expansion? All the powers are something. All right, I need some coefficients in here. This has got nothing. This is just a 1, rather. This is 5. Choose 1, which is a 5. 5, choose 2. 3. How are you doing? Are you beating me to it? 5, choose 5 at the end, right? So here we get 243. P to the 10th. Check your work with me here. And then 5 times 81 is something. 405. P to the 8th. All the powers are nice, huh? Right? 5 choose 2 is 10. Times 27 is 270. P to the 6th. Plus 5 choose 3 is also 10. Times 9 is 90. P to the 4th. Plus 5 times 3 is 15. P squared. Check my arithmetic on all those, but I think we got it. Yeah? You like that? All sorts of cool things we can do with this. Like this one, which I'll send home with you. You ready? Are you ready? We'll make sure you're prepared. No, it's not too bad. I just think it's interesting. That's all. It's not bad. So the reason I say that I think you'll take it home with you is because we're also gonna bring in about a minute or two. But I really would rather not just like give you the answer. I think it'd be more fun for you to like labor on this. Figure it out. You can talk to your table about it, but I'd like you to figure it out. Just for fun. So hopefully we're like getting a little bit quicker with this binomial algebra here. We got our little trick, and also hopefully we understand why it's working for us. You didn't see algebra coming in on this one, did you? It came out of nowhere. Combinatorics turns out to be useful everywhere. You figured it out yet? Come see me if you have the answer. I love you, bye.